Alright, so Unit 14, Day 1. Unit 14 is all about exponents, okay? How we manipulate them and how we move them around and make them into things that we can deal with and work with. Now, we're going to start off with some definitions, okay? So, base of a power. Okay, so the base of a power is the number that is to be raised that is to be raised to a power. Okay, now examples of this. If we have, say, 13 raised to the second power, 13 is the base. If we have, say, x to the fourth, x is the base. If we had, say, x to the, negative fifth, okay, x is still going to be our, x is still going to be our base, okay? Now, an exponent, okay? The exponent is the superscript that tells us how many times we will multiply the base by itself. Okay? The superscript that tells us how many times we will multiply the base by itself is the exponent. Okay? So, things that are exponents. So, if we had, say, 13 to the fifth, 15 is the exponent. If we had, say, x to the second, 2 is the exponent. If we have a to the negative third, negative 3 is the exponent. Now, we got some special occurrences here. 0 exponents. Okay? A 0 exponent is going to be, an exponent of 0, an exponent of 0 will always result in 1. Okay? So, if we had, say, 1236, we raised it to the 0 power, that's going to equal 1. If we have, say, x raised to the 0 power, it's going to be 1. If we had z raised to the 0 power, that's going to be 1. Doesn't matter. Whatever you raise to the 0 power, it's going to be 1. Now, negative exponents. Okay? Negative exponent will be flipped. Okay? So, a negative exponent, let's say that we have, so negative exponent, flip the number. Okay, if we had, say, 2/3 raised to the negative 2, that's the same thing as saying 2/3 squared. Okay, if we have, say, x over 2 raised to the negative 3, Okay, that's going to be the same thing as saying 2 over x raised to the third. Okay, so on and so forth. Notice I'm flipping it over and the negative sign has gone away. The negative sign goes away whenever you flip it over. Now, if I had, say, x raised to the negative third over 12, okay, I'm going to flip the x down to the bottom. That's going to be 1 over x to the third times 12, okay? Need to rewrite that. That's going to be, again, it's going to be 1 over x to the third times 12, okay? I just moved the x to the third down to the bottom and removed the negative sign. Make sure that y'all remember to remove that negative sign. It helps a lot. Alright, now down here we have some information, okay, about the patterns that occur for negative exponents and all that good stuff. Now, this is what I was just saying a second ago, okay? A 0 exponent, the answer is always 1, okay? Okay, helpful, useful information. Now, right here, negative exponents, the answer is the reciprocal of the same expression with a positive term. Okay, when it says reciprocal, that just means that you're going to put that under 1. Okay, so 3 to the 4th equals 81. Okay, 3 to the negative 4th, though, equals 1 over 81. Okay, that negative right there makes things go under the division bar. Now, note that the rules are the same when the base is a variable. Okay, just some helpful little things right here. So b to the third is the same thing as saying b times b times b. G to the 0, same thing that we said right up here. Okay, that the answer is always going to be 1 when we raise something to the 0 power. Okay, k to the negative 5, k goes into the denominator. 1 over m to the negative third. Now this is going to be pretty useful at some point in time, I'm sure. So m to the negative third is the same thing as saying, or 1 over m to the negative third, rather, is going to be the same thing as saying m to the third. Okay? So let's go ahead and start working on some of these practice problems. Alright, so page 2. Okay, it's starting us off by talking about simplifying expressions with negative exponents. Now, it says for a negative exponent in the numerator, ... Okay, so what do we do for a negative exponent in the numerator? Okay, what I would do is I would say something along the lines of put in denominator and drop negative. Okay? Now, just as a side note, okay? When I say negative in this case, I mean negative from the exponent. Okay? That's important. Okay? Don't drop the negative from the actual number, but from the exponent. Okay? Drop. Drop. Don't drop. Okay? Now, for a negative exponent in the denominator, okay, we're going to do the same thing. We're going to accept backwards. We're going to put in numerator, okay, and drop negative from exponent. Alright, so let's go ahead and do some of these practice problems real quick. On number 1, it says 4 to the third. Okay, now this is what I want to see on y'all's paper. I want to see 4 times 4 times 4. Okay, 4 times 4 times 4 is going to be what? $64. Alright, now number 2. Okay, same concept, same thing that we've been working with. Okay, we're gonna go see this negative right here. We're gonna treat this as a negative in the numerator. Okay, so that means that we're gonna put it down in the denominator. That's gonna be 1 over 5 times 5, which equals 1 over 25. And there's our answer. Alright, so number 3. Okay, what we're going to do with number 3 is we've got this negative right here, so that means that we're going to go 1 over negative 5. And there's that. Okay? Alright, so number 4. If you notice, we have this exponent that is a negative exponent. So what we're going to do is we're going to go ahead and put this under 1. Okay, so that's going to be negative 4 times negative 4 times negative 4. Alright, so 4 times 4 times 4, that's going to be 64. Negative times negative is positive. Positive times negative is going to be a negative. Okay, so that's going to be 1 over negative 64. Alright, and there's that. Alright, now, this one, okay, very similar problem, okay, but no negative on the front, so that means that we're going to go 1 over 4 times 4 times 4. Alright, now this is going to be positive 1 over 64. Alright, now we've got 2 to the 4th. I love powers of 2, they're so nice and convenient. So we got 2 times 2 times 2 times 2. So we got 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. Okay. It's not too bad, not too shabby. Alright, now, x to the 0. Okay, just like we said, anything raised to the 0 is going to equal 1. Period. Okay? Hope that y'all are paying attention when I say that. Okay? Now, this, okay, this is really 4 times x to the 0, okay, which is going to equal 4 times 1, which equals 4. And that's done. Okay? I'm going to rewrite that. Okay? So we've got 4. Alright, now, here we've got this whole thing is raised to the 0. Over here, if you notice, the 0 was just with the x. On this one, since we have these parentheses here and here, it's going to make it to where this whole thing is raised to the 0, which makes this equal to 1. Alright? Alright, now, number 10. Okay? So we've got 3 times x to the negative 4th. Now, if you remember correctly, this x to the negative 4th, when you have that negative exponent, it's supposed to go into the denominator, okay? But there is no negative exponent attached to the 3, okay? So what that yields is 3 over x times x times x times x, okay? Which is the same thing as saying 3 over x to the 4th. And there's that. Okay? Alright, now, moving along here. Okay, we got number 11. Okay, with number 11, we have 3x raised to the negative fourth. Okay, so what we got to look at is we're going to have to put this whole thing under 1 now. Okay, so 1 over 3x to the fourth. Alright, so what we can do now is we can do 3. Okay, so 3 raised to the fourth, we can do 3 raised to the fourth and x raised to the fourth. So that's going to be 1 over 81 x to the fourth. Alright, so number 12. Number 12, what do y'all think is going to go in the top? What do you think is going to go on the bottom? The only thing that's going to go into the bottom is the x to the third. Okay, these have positive exponents of 1 and 1. Okay, so that means that's 4y over x to the third. And that's done. Okay, you got to make sure that you're paying attention to your parentheses and all that good stuff. Okay, if it's in parentheses, then it's going to be included with whatever exponent was on the outside of it. Okay? No parentheses, they're on their own. Okay? Alright, number 13. Okay, we've got b to the 0, which is going to be 1. And then this right here, which is going to be 1 over a to the fourth, right? So let's go ahead and combine those together. So that's going to give us 1 over a to the fourth. There we go. Alright. Now, if we look back up here at the top for number 14, okay? If we have an exponent in the denominator, it says to put in numerator and drop negative from exponent. Okay? So, we're going to take this, put it in the numerator, and then drop the exponent. So x to the negative third is going to become x to the third, and that's it. Alright, now, on number 15, we have a bit of a double cross, okay? This is a negative, that needs to go down. This is negative, that needs to go up. So what we have is y squared over y cubed, or rather, x cubed. Alright, that's not too bad. Now, moving along. Okay, if you notice, we got this negative exponent right there. Okay, that means that needs to come down. Okay, no negative exponent on the x, so that means that we're going to have 1 over 25 x. Alright, now, let's see. Number 17. What's going to happen here is we're going to have negative 3 going down. And then negative 6 is going to come up. So that's negative 6 times negative 6. Okay? And that's going to be 36 over 3, which equals 12. Okay? Alright, now number 18. Alright, so that needs to go up. That needs to go down. Okay, so that means that we're going to have 4 over 64. Okay, and then 4 goes into both of those. 4 goes into 64 16 times. So what we're left with is 1 over 16. Alright, now number 19. We have 6x raised to the negative fifth, y raised to the sixth, and w raised to the negative third, z to the 0. Now, this z to the 0, we know that's going to be 1. Okay? W to the negative third, that means that we need to go up. This needs to come down. Okay? So that means that we're going to have 6 w to the third, y to the 6th, over x to the 5th, z to the 0, which is 1. Okay? You can actually drop the 1 if you feel like. Okay? Alright, now, last one on this page. We got negative 8 times 2 raised to the negative 2. Alright, now, negative 8, that doesn't mean a negative exponent. That just means that it's a negative 8. So we're going to put negative 8 right here. Okay, and we know that this means that we got to go down. Okay, so that means 2 times 2, which equals negative 8 over 4, which is negative 2. Done. Alright, so last little bit here. So it's asking us to use the following information to answer question number 21. Allison has an interest in entomology, the study of insects. Her collection of insects from around the world includes the 4 specimens shown in the table below. Select the best answer. Okay, many giant wettas are so heavy that they cannot jump. Which expression is another way to show the mass of this specimen in Allison's collection? Now, it's referring to this line right here. Okay, so if you remember, the negative 4 exponent means that we're going to have 1 over 2 to the 4th. That's the same thing as saying 1 over 2 times 2 times 2 times 2. Okay, now, kilograms. So the only one that winds up looking like that is H. And that is just about it. We got one more question. Alright, so James is using the formula for the volume of a sphere to determine the value of pi. He is using the expression 3/4 of VR raised to the negative third, where V equals 268.08 and R equals 4. So, what I see here, okay, what I'm seeing is 3/4 times 268.08 times 4 raised to the negative third. Okay, so we've got some sorting to do here. Okay, got a little bit of sorting that we need to take care of. So what we can do is we can take this 368, put it on the top of a fraction, okay, along with the 3. Okay, so we got 3 times 268.08. That's going to be over 4 times, and if you remember, this negative exponent means that we're going to put that in the denominator, 4 raised to the third. So when we do 3 times 268.08, what we get is 804.24. Okay, and then we're going to do 4 times 4 times 4 times 4 on the bottom. It's going to be 256. Okay, so now what we need to do is we need to go ahead and find out what that winds up equaling. So we got 804.24 divided by 256. And I got 3.1415. Alright, now it says that we need to find the value of pi to the nearest thousandth, okay? So if y'all remember place value stuff, okay, we got 1, okay, this is the tenths, the hundredths, and the thousandths. Now this 5 right here tells us that we're going to round this up. So what we're left with is 3.142. 3.142. All right, and that concludes the notes.